Good morning, guys. Meteorologist Nick Lilly here looking at the severe weather threat come later this afternoon. And, well, right now we're looking at twisterdata.com. Great website, by the way, if you are interested in meteorology or you want some more meteorological information. You want to look at the weather maps and all the data instead of listening to your local weather guy, who, by the way, knows a lot about this stuff. But if you're ever interested and you're curious and you want to take a look at this stuff, well, you can, because it's out there. What we're looking at right now is actually the vertical velocity map, if I remember correctly. Yep, vertical velocity here at about 700 millibars or so. And what we're looking at in here is kind of this area right there or so. And what we're tracking is, this is the oomph that we have in the atmosphere. This is what we're trying to look for, is how much vertical velocity that we have in the atmosphere. And, well, we've got a fair amount in here, and this will come into play coming up here in just a little bit. But right now, let's see if we can clear this guy out. There we go. We're going to head over here. Now we're going to look at wind speeds at about 200 to 250 to 300 millibars or so. This is a little higher up in the atmosphere. There we are, about 300 millibars or so. And what we're looking for here is we want to spread these lines further apart here. And as we do so, what we're doing is opening up the atmosphere and allowing some of that vertical velocity to go somewhere. So for example, if you've got all this vertical velocity but you don't have any spreading apart in the atmosphere above it, all that air that's moving upwards doesn't really have the ability to move upwards. There's nowhere for it to go. Well, when you spread it out like this, these are isobars of similar pressure, lines of similar pressure. When you spread those apart, you're lowering the pressure in between them and allowing for that vertical velocity, that air that wants to move up, to move in there. Now, as we take a look at the composite reflectivity, this is basically estimated radar in a sense. So what we're tracking for later this afternoon is, it's suggesting, now this is the 12Z wrap, that we'll see a couple of showers and thunderstorms fire off in parts of Missouri, Arkansas, Oklahoma, and in Texas. And as we'll see here in a little bit, this completely makes sense. But notice how this lines up pretty closely. In fact, we can just switch right back over. Notice how it lines up pretty closely there, not only with where we're spreading things out, but also where we've got that vertical velocity. You can see we also have that opportunity for a little bit of rain. In fact, as we kind of zoom along here, now we're looking at CAPE. This is the potential energy we have. This is basically a measure of instability in the atmosphere. And we've got some pretty decent CAPE. Oftentimes, you know, we've got about 3,000 right there. Oftentimes, when we're looking at CAPE, anything above 1,000 is going to give you a pretty decent thunderstorm. Anything above 2,000 is going to give you a pretty strong thunderstorm. And once you start to get up above 3,000 or so, given the right atmospheric conditions, you can break off some pretty strong and pretty severe thunderstorms. And we got some 3,000 down here. We also have a little bit back here up into parts of Missouri and in Arkansas. But really what we're talking about, as you look at the key back behind my head, for the most part, this entire area here, all of this, is in about the 2,000 to about 2,500 to 3,000 range. So, you know, as we look at that, and then we look over here, again, this is all the stuff that we look at. This is all available to you that you can find if you want to go out and do all this fun stuff. Now we're looking at the EHI value, and oftentimes what we look at here is anything between about 1 and 3 or so can usually spell pretty large hail and the opportunity for some tornadoes. And for the most part, down here in that first area that we were looking at, right now, let's slide back over and take a look at this key. That's what I thought. Just about 1 to 1.5 or so. It's when you get back up into here, parts of Missouri, northeastern Arkansas, southern sections of Illinois, and western Kentucky and Tennessee, that you get up to the 2s and even close to the 3s. So you look at that and you've got basically EHI. It's a measure of how much torque we have in the atmosphere. Give or take, it's the energy with helicity. And then you look at that and you say, okay, cool, those two places match up pretty nicely where we've got some decent instability. And we head back here and you say, okay, cool, composite reflectivity is there, so it looks like we're going to have some showers and thunderstorms in the area. And you're looking at this and you're saying those showers and thunderstorms will have an opportunity to have some pretty good vertical motion with them as well. And then, well, let's clear that out and let's move on to the next guy here. Now what we're looking at is how low the bottom of the clouds will be exactly. Where you see all these really bright purples and reds, that's where your cloud bases are going to be that much higher. Where you don't see anything, you know, as you head your way up into parts of Missouri up here, even trying to sneak into that same area in Oklahoma, parts of Texas and Arkansas. Now, when you get down when there's just nothing up here, you're talking about cloud heights at anywhere between about 500, 1,000, and 1,500 meters or so. And that's what you need when you're talking about the potential for tornadoes. You want those low cloud decks. Oftentimes, if you watch storm chasing videos or if you're watching a thunderstorm develop, the lower the cloud deck, the easier time it has actually producing a tornado. All we're going to do is we're going to go ahead and highlight this area again and these areas up here, and then we're going to flip back and we're going to say, okay, cool, well, that's a place that we have the opportunity for some good torque, we've got some good lift, that's where we're going to have showers and thunderstorms. This is all starting to make sense, isn't it? And so let's clear this out again, we'll move on to the next one. Here, what we're looking at is the lifted index. Now, this is basically how quick we're lifting stuff out there, how fast these parcels of air are moving vertically in the atmosphere. And oftentimes we look at this and we say, well, anytime you can get above a 4 or so, you've probably got some pretty decent lift. And this is all working in negative numbers. It all works itself out when you do the mathematics. But for our purposes here, we'll go ahead and talk about it as a 4, 6, 8, 10, etc. But just know we're talking about negatives. I'll try and speak in negatives as best I can. We've got a -9 down here, a -8 up here, a -7 right here. So we've got some pretty good lift all throughout this area. Some good oomph to get things going. And recall, this is the same area as we go back that we're talking about some decent vertical velocity. Really, the vertical velocity also stretched back down into Texas. We'll get to why that's important here in a second. But, you know, as you kind of look at it, you're going, okay, most of the oomph in the atmosphere is well back off to the north and east of the original place. Okay, cool. So now we're looking at helicity. This is how much spin we have out there in the atmosphere. And any time that you can get above 300 here, we're usually talking about some pretty decent spin. The only thing that saves us today is right now in that same area. We're talking about 100 to 200 or so on our helicity index. And again, that's the same place where we've got vertical velocity, we've got spreading in the atmosphere aloft, we've got composite reflectivity as shown by the 12Z wrap here. We've got some good capes, some good torque, and we've got low cloud decks, and we also have some good lifted indices. So we're moving that air vertically pretty quickly. Alright, so that all lines itself up, which is why the SPC today is talking about that area for severe weather. Now let's take it all the way back. We're going to slide all the way back over here and look at one of the weather models. And as we put this guy into motion here, notice that this is where those storms start to fire, also in parts of Missouri and Arkansas. But this is about 2, 3 o'clock later this afternoon. We're going to set this guy into motion and notice how they lift and fire right into that same area that we were just talking. That same area that has the good oomph, a lot of lifted. It's got some good torque, some good spin to it. And this is where, at least this computer weather model, suggests that all these storms are going to fire. Well, what about the other one? We can flip it on over, we can look at the HER. Well, the HER is saying pretty much the same thing. I mean, here we are at about, let's go all the way back, here we are, into the afternoon here. We start to fire showers and storms, even near the Metroplex of Dallas as you make your way just off to the south and east of Tulsa, and into that void into parts of northwestern Arkansas. But look at how these storms just explode and eventually try to turn linear, but notice that at the beginning here we are talking about supercells. We've got one here, one here, one there, one or two or three here. These are discrete cells, and this is when you're more likely to see a spin-up of a tornado. That said, this is about, we've got a 22:15 or so, so we're sitting at about 8, 9, 10, 11 o'clock at night. Nocturnal tornadoes, very scary, but are possible across parts of Missouri, Arkansas, and parts of extreme eastern Oklahoma and east Texas. And notice as we take this guy out, things eventually become linear and start to kind of fall apart as we head into the overnight hours. The other one that we can look at, this is the Texas Tech Wharf. We set this guy into motion. I mean, here we are. This is at about 11 o'clock or so. That's when it says these are going to start to fire. But notice doesn't really do much with these. Texas Tech Wharf, not unimpressed. It's the Maroney, Michaela Maroney, giving us the unimpressed here. Not much to it before everything falls apart as we head into about midnight or so. So again, what we like to do is give you guys kind of some background information about what we're looking at and why we decide to issue our graphics that say, hey, this is where we're looking at severe weather, this is where we're not looking at severe weather. I hope you guys enjoyed this breakdown. And remember, if you're living in parts of Arkansas, Missouri, extreme eastern Oklahoma, Texas, and northern Louisiana, heads up for severe weather today.